everyone. Welcome to the Gentio Training Academy. Today's topic, Cluster Component Architecture. When we talk about production-grade AI systems, everything runs on one backbone, Kubernetes Cluster Architecture. Let's break it down component by component. First, the control plane. At the heart of every cluster is the control plane, powered by the kube-apiserver. This is the brain of Kubernetes. Every kubectl command, every CI/CD deployment, every operator action goes through the API server. It validates requests, stores cluster state inside etcd, and triggers the necessary controllers. If you're using managed services like Amazon EKS, Microsoft AKS, or Google GKE, the control plane is fully managed, zero operational overhead, enterprise-grade reliability. Next, etcd. etcd is a distributed key value store. It holds the entire cluster state, pods, services, secrets, config maps, everything. In managed environments, etcd comes with automated backups, typically every 30 minutes, to secure object storage. This ensures disaster recovery and state consistency. Now, the scheduler. The scheduler decides where your pods run. It evaluates resource requests, CPU, memory, node affinity rules, taints and tolerations, topology spread constraints, and, most importantly for AI workloads, GPU availability. Inference pods and training jobs get scheduled intelligently onto GPU-enabled nodes. Next, the controller manager. This component runs core controllers like replica set, deployment, stateful set, and job. It constantly compares the desired state defined in your Helm charts with the actual running state in the cluster. If something crashes, it self-heals. That's Kubernetes reconciliation in action. Now let's move to the worker nodes. First, kubelet. Kubelet is the node agent. It pulls container images, starts and stops containers, reports node health, and enforces CPU and memory limits. Without kubelet, pods cannot run. Then we have kube-proxy. Kube-proxy manages networking rules using IP tables or IPVS. It enables service-to-pod communication inside the cluster. However, in service mesh environments like Istio, kube-proxy is effectively enhanced by the Envoy sidecar for advanced traffic control, observability, and security. Finally, CSI Drivers. CSI stands for Container Storage Interface. These drivers provision persistent volumes dynamically. For AI workloads, storage matters. AWS EBS for stateful agents, AWS EFS for shared vector database index storage, AWS FSx for GPU checkpoint files. Each storage layer is optimized for a specific workload requirement. So when you look at Kubernetes cluster architecture, you're not just seeing containers. You're seeing a distributed control system, a self-healing infrastructure engine, a GPU-aware AI orchestration platform, and a production-ready deployment backbone. This is how modern AI systems scale reliably. This is Kubernetes, engineered for real-world AI workloads. Thanks for watching. Don't forget to like, share, and subscribe for more deep tech content on Docker architecture for AI workloads. Thank you all.